The last thing that I want to talk about today a little bit more is isotopic notation. And in that PhET simulation, there were a couple of things we asked you to do. And so let's just go back over one of the questions where it was asking you about oxygen 16, 17, and 18. Before we do that, though, let's take a look at what isotopic notation is. We have to remember that this top number is what we call the mass number. And don't complicate that. The mass number is a combination of the protons plus the neutrons in the nucleus of an atom. The bottom number is the atomic number, which you must remember represents the number of protons. So if we were trying to figure out how many protons and how many neutrons are in this isotope, the number of protons is always this bottom left number. This nitrogen has 7 protons in the nucleus. And now to figure out the number of neutrons. 15. You know that there are 15 total particles in the nucleus. You know that 7 of those are protons, which means how many neutrons are there? Because you know protons plus neutrons gives us 15 because that's the mass number. That tells us that there must be 8 neutrons in the nucleus of this atom. So key thing, the bottom number is always your number of protons. To find the number of neutrons, you're going to subtract the top number minus the bottom number to find the number of neutrons. Now let's take a look at potassium. If you look at your periodic table, that capital K represents potassium. And what I'm asking you to do here is to identify the number of protons and neutrons in each one of these isotopes. I know that they're an isotope because I see that isotopic notation. So here we go. Notice when we look at these, that 19 is always there. And that's because that's the number of protons. Anytime an atom has 19 protons, it's telling us that it's potassium. So this one has 19 protons, this one has 19 protons, this one has 19 protons. They all have the same number of protons. Remember, if we were to add a proton and make that 20, it would become an entirely new element. Now let's take a look at neutrons. You know that that 39 is the mass number. That's a combination of the protons plus the neutrons. Well, if there are 19 protons, how many neutrons must be present? Remember what I said earlier, subtract. 39 minus 19 gives me 20 neutrons. How many neutrons are over here? 40 minus 19 would give me 21 neutrons. And over here, 41 minus 19 would give me 22 neutrons. And so here's my point. These are all isotopes because they all have the same number of protons, different numbers of neutrons. Those are our two conditions that we have to look for when we're identifying isotopes. They all have 19 protons, but they all have different numbers of neutrons, again, making them isotopes of each other.